So question number 6 is let x1, x2, xn be the random sample from a gamma alpha beta population where alpha, beta is more than 0 is known. So beta is known, okay. So beta is not parameter here, only alpha is. Beta is known constant. The rejection region of the most powerful test for h0 alpha is equal to 1 against h1 alpha is equal to 2 is of the form. So we need a rejection region for the most powerful test. So we have to use Neyman-Pearson lemma for the rejection region of the most powerful test. So for that, so if x has gamma distribution with alpha beta, so it's a PDF is 1 upon gamma alpha beta raised to power alpha x raised to power alpha minus 1 e raised to power minus x upon beta when x is positive. So this words when x is positive. So let's calculate first likelihood function. So it's a L alpha x1 x2 xn. So this is product of f of xi. So that is product of 1 upon gamma alpha beta raised to power alpha. Let's first write e raised to power minus x upon beta. So xi. So replace xi upon beta and xi raised to power alpha minus 1. So product I from 1 to n. So L of alpha x1 x2 xn is, when you take this outside, so it is 1 upon gamma alpha beta raised to power alpha whole power n, because of the product n time e raised to power, then we will product, so e raised to power x1 upon beta and so on. So it's a minus summation xi upon beta, and this is product xi raised to power alpha minus 1 I from 1 to n. So we need critical region for the most powerful test. So by Neyman-Pearson lemma, L of alpha 1 upon L of alpha naught, this is more than some constant k, or let's say k1. So in place of alpha, we put alpha 1. So alpha 1 is what? In the given in the alternative hypothesis. So alpha 1 is given 2 and alpha naught is given 1. So in place of, in numerator, so in place of alpha, we will use alpha 1, so 1 upon gamma of alpha 1 beta raised to power alpha 1 whole power n e raised to power minus summation xi upon beta and product xi raised to power alpha minus 1 I from 1 to n upon 1 upon gamma alpha naught beta raised to power alpha naught whole power n e raised to power minus summation xi upon beta product xi raised to power. So this was alpha 1 minus 1, this is alpha naught minus 1, and this is going to be more than some constant k1. So let me write it again. So in place of alpha 1 we have to put 2. So 1 upon gamma 2 beta raised to power 2 whole power n into, so this thing will be cancelled out, right? So we are left with product xi raised to power alpha 1 is 2, 2 minus 1, where I from 1 to n upon denominator 1 upon gamma alpha naught is 1 gamma 1 beta raised to power 1, this power n product xi raised to power 1 minus 1, so I is from 1 to n, this is more than k1. So this implies, now since gamma 2 is 1 and it's a beta square, gamma 1 is also 1, so it's a beta, so we get 1 upon beta raised to 2n upon 1 upon beta raised to n. So product xi raised to power 1 I from 1 to n in the denominator 1 minus 1 is a 0, so xi raised to power 0 is 1, so 1 into product n times, so 1, which is more than k1. So product xi, I from 1 to n is more than k1 time beta raised to power n upon beta raised to 2n. So since n, beta and k1 all are constant, we can rename this as suppose capital K or some other constant c. So the critical reason for the most powerful test is this is more than k. So this is critical reason, and that was asked. So product xi is more than some constant k. Product xi is more than some constant k. It's a first option, right? Product, yes. So we got most powerful critical reason of most powerful test for null hypothesis or for rejecting null hypothesis is this. So A option is correct.